In this Algebra 2 video, I'm looking at these three problems dealing with Brutus and his bank account. This goes back to concept 22. It says Brutus has a savings account that earns 2.3% annual interest compounded continuously. That's a big hint for our equation. His balance is currently $7,000. It says write an equation that represents the value of Brutus's account each year. So we're starting with, we'll have y equals, just to start the equation, our initial net value is starting with $7,000 times, and then when it's compounded continuously, whoops, went too soon, that's when we're using our value of e, our constant term of e. Now the exponent is where a lot of people forget and make some mistakes. The exponent here has to do with this annual interest. I have to take that 2.3%, but I have to change it to a decimal, which means I have to take the original decimal, move it over twice. So the exponent becomes e to the 0.023 times t for time. Because at some point we're probably going to look at how much time this money is in this account for. So there's my equation. 28 says how long, rounded to the nearest hundredth, will it take Brutus's balance to reach $8,000? So what we're taking this equation, the output would be the y. So we're saying that y value is going to at some point be 8,000. So what we're wondering is, again, how long this takes to get 8,000. So we're solving for t. Now if we're starting with 8,000 equals 7,000 times e to all this, we're going to divide by 7,000 first. Cancel. All these zeros cancel. Leaves me with 8 over 7, and I don't think that divides nicely. I will check in my trusty calculator. 8 divided by 7. And it's pretty long decimal, so what I'm going to do is I'm just going to leave it as 8/7 equals e to the 0.02 times t. Now again, the idea is to solve for t. So what we have to do now is to eliminate this constant term of e. I have to take the natural log of both sides. What happens is this cancels. So now I'm left with natural log of 8 over 7 equal to, I'm going to answer you later. You leave a voicemail. Equal to 0.023 times t. Now the idea is, again, to solve for t, now I have to divide by that decimal. So I'm going to take both sides, and it looks ugly, but we'll see how this works, and divide by 0.023. So now if I go to the calculator, I'm going to take the natural log, there's my ln button on the left here, down here, the natural log of 8 divided by 7, close parentheses, that's this numerator, and I'm going to divide that by 0.023. This gives me the time, and it rounds off to 5.8, it looks like. So this will be 5.8 years approximately. 29 says, how long ago, rounded to the nearest hundredth, was Brutus's balance 5,000? So I'm going to take that equation. Instead of it being 8,000, it's going to be 5,000. So it's going to look weird at first. 0.023t. And again, it's the same idea. I'm taking both sides, dividing the same process as before. I'm left with 5/7 equals e to the 0.023t. Natural log on both sides. So that's the natural log of 5 over 7 equals 0.023t. Divide both sides by 0.023. And then it's into the calculator from there. So again, let me move this. Yep. Natural log, 5 divided by 7, close parentheses, divide that by 0.023 equals, now notice it says it's a negative. So at first it thinks, well, negative 14.6 years, you can't have a negative amount of time, but remember that the question was asking how long ago. So really what we're saying is that it was, and it rounds to 14.6, it was 14.6 years ago that the account had that amount of money in it, that it had $5,000 in it. and there is 27, 28, and 29.